Uh, so, uh, Good evening, everyone. I am Romit Kavre. I'm currently working as a research fellow at MRC. I am discuss about the sediment management in the Indo-Pacific. Now, this is something that I have been working since the past 2 years now. So, I'll start with understanding how what are basically how the sediments are very much crucial in the water systems. Uh, the sediment fluxes, what are the various sediment levels, the siltation level, is very much crucial to understand how are the effects of the various human influences or the various natural processes that have shaped the sediment flux. Uh, for this, now this sediment flux has very much importance in various domains. So we have the water quality, the sediment classification, the topography, the bathymetry. We'll talk about it later in the discussion. But this has wide-ranging applications in a lot of domains. Now, typically, the sediment management plans, whenever they are being developed, they are mostly developed considering what are the various local conditions. Now, when we talk about the Indian subcontinent or the tropical region of the Indo-Pacific, we do not have basically understanding of the various of the local dynamics, what are the local conditions that shape the various sediment dynamics that are there. Now, due to this, there is a lack of data collection and then holistic planning purposes. In fact, when we talk about the role of the sediment, it has very much economic, environmental, and social role as well. Thus, what are the various sediment monitoring techniques? Understanding the various sediment dynamics becomes imperative. For this, what we are trying to see is within the sediment management, how can we uh, how can we have an holistic view which would integrate the various the water quality, the sediment flow, the sediment dynamics, and once the sediment has been properly deposited, how does it shape the various applications that are there. So. We talk about sediment management, we're mostly concerned with the two systems that are there, the freshwater systems and the coastal regions. Each of their own nuances, we need to properly understand them. When we talk about the freshwater systems, there are the major river systems are there. We have the dams and reservoirs. So when we talk about the river systems, we have the Ganga, the Brahmaputra rivers. These experience excessive sedimentation, especially during the monsoonal season that we have the intense monsoonal system. Apart from that, we have excessive soil erosion. This soil erosion and various agricultural practices, this leads to a lot of sedimentation, the sediment inflow into these river systems, and this affects the efficient working of the inland water systems that are there, various the freshwater marine ecosystem is there. This also, the excessive sedimentation also affects the storage capacity of the various major reservoirs that are there. So the Central Water Commission of India, it has estimated there is an annual reduction of around 1.5% of storage in the major reservoirs, especially due to the siltation that is there. So freshwater systems, it has a wide-ranging applications concerning the total watershed that is there. Now, when we talk about the coastal regions, they boast a different type of ecosystem. So it boasts various estuaries, deltas, the coral reefs are there, mangrove systems are there. So it has the river and the sea interface. Basically, it is there. Apart from that, the coastal regions also boast the port systems that are there, which are very much crucial for facilitating the global trade. Apart from that, the exclusive economic zone is there, which is crucial for the oil and gas exploration or various navigation purposes as well. And with the rise in the human interventions in the exclusive economic zone, we need to understand their case studies. What are the requirements in the coastal regions? What are the challenges that are faced in the coastal regions? Now, all of the sediment management, we are mostly concerned in the two major aspects, that are the sediment classification and the sediment transport. Now, sediment classification is basically understanding what are the various sediment types, understanding the various properties of the sediments, what is the seabed layer, what is the depth and thickness of the sediment bed layer. This has applications in various uh, defense purposes. When we talk about offshore construction, navigation, we have the benthic ecosystem monitoring. All of these are characterized by the what is the bathymetry or what is the seabed characterization at the part that we are credited. In fact, the seabed is characterized by the various natural processes that have occurred over millions of years, and what are the current what is the current condition needs to be properly assessed. For example, if we have to build a refinery or some offshore construction needs to be done, found understanding the seabed characteristics is very much crucial for the foundation design of such crucial infrastructure. Apart from that, we have the polymetallic nodule program. The sediment classification techniques can be useful in this in assessing the polymetallic nodule viability, and also understanding the and monitoring what are the various we have the marine trash, the marine litter, or these various microplastics that have been buried within the sediments. Sediment classification techniques can help us in identification of the various what are the various components that are present in the seabed in the biotic as well as in the abiotic part of the ecosystem. The other part is the sediment transport. Now, this sediment transport basically means what are the various natural or the human processes that shape the sediment flux. It's a transportation, it's deposition. What are the various natural there are natural phenomena, coast. It is also interlinked to the various coast erosion processes, agricultural processes that are there, the monsoonal system. Sediment transport has implications on the various applications because if we do not understand what are the localized sediment dynamics, we can't have proper monitoring efforts. In fact, when we talk about our port systems or the inland waterways, we have to conduct regular dredging. But what is the use of such regular dredging if we don't understand what are the local sediment dynamics that are there? Because once we have a particular project without understanding the local sediment dynamics, uh, it just goes into waste as again due to the natural phenomenon, the sediment might again get transported into the very same place. The sediment might get accumulated, and it may hamper the effective movement of navigation of the various ships that are there, which may require again regular dredging would be required. So we need to understand what data needs to be collected regarding what are the localized sediment transport in a particular region. Now, all of this sediment management, the sediment classification, and the sediment transport, why are we very much focused on the tropical conditions or the Indian subcontinent? So the Indo-Pacific is the Indian Ocean is the warmest among the major oceans. Now, this higher equatorial temperatures leads to an intense monsoonal system. This again has this affects the urban floods that are there, or excessive sedimentation are there within our major water systems or major reservoirs that are there. Apart from that, the Indian Ocean it boasts around 30% of the global reef cover. It has 40,000 square kilometer of the mangrove that are there. It has nine major marine ecosystems. So it also has a rich biodiversity, and we do not have a proper understanding or proper knowledge of the distribution of such biodiversity. What are the effects of the various human activities that are there, or the effects of the climate change? Thus, we need to have proper data collection systems in place. Now, when we talk about the underwater monitoring as well, when we talk about acoustics, the Indian Ocean behaves very uniquely. So the SOFAR channel depth, which is linked to the proper underwater communication, the SOFAR depth is very much higher in the Indian Ocean region, thus rendering it acoustically shallow. Now this leads to a lot of multi-part propagations. When we talk about the working of the acoustic systems, there is a lot of acoustic and noise that the tropical use within the data. So when we talk about the data collection systems, there are various new sensors or the remotely operated vehicles, autonomous underwater vehicles have been developed in order to collect the data that has been there. But again, proper research and development needs to be undertaken in order to find out what are the proper appropriate sensors that are required. So there can be the multi-beam echo sounder, the side scan sonar, each having their own application, each have their own frequency and resolution trade-offs. Understanding what are the various what are the appropriate sensors that are required for our application. Thus, there are a lot of development challenges in developing an in-house monitoring system. So the Indian ocean or the tropical conditions, it leads to a lot of variability in the raw data. There are a lot of noise and the medium surface and bottom fluctuations are there. So whenever the acoustic systems are brought into or are deployed in this system, there are challenges in deploying them, in calibrating and maintaining this equipment. In fact, there are a lot of constraints in the equipment and operational cost of such equipment. Now, this leads to an decrease in the operational efficiency to around 60 to 70%. Now, reduced efficiency, we have to mostly depend on the Western nations that are there, with India not able to develop its own indigenous systems. Thus, with the advancement of technology, we have the Internet of Things, the AI, the 5G technology. We can have real-time data transfer. We can have real-time data analysis. How can we integrate them with the current conventional techniques? So, when we talk about the sediment transport mechanics, how can we integrate the real-time data, real-time feed to find out the current, what are the various current processes that shape the sediment deposition that are there. We can also have a shared data system so that we can share real-time data with the various stakeholders that are there, which would be very much crucial for the real-time data processing. We have the data analysis and then proper decision making between the various stakeholders that are there. That's what we are trying to develop, is the 2C, to understand and the to share concept. So in the 2C, we are trying to see for each of the application that we have is of interest, what kind of hardware, what kind of sensors are required for that. And once the various sensors are found out, what are their specification, how are they going to be deployed, what kind of data processing needs to be done to the collected data. The tropical conditions have a lot of noise and multi-part propagation. What are the filtering techniques? How are we going to interpret the data? Because again, different stakeholders have their different requirements. So based on their need, how are we going to understand the various data processing techniques? And then finally, how this data is going to be shared between the various stakeholders. That comes under the to share part. In this, how the UDA will help. So basically, at its core, the UDA talks about the competence of the acoustic systems, developing the sensitizing the various stakeholders, taking in what are the specific needs, and then leading to a digital transformation. In this, we would like to have a digital. We would like to have the outreach for the various stakeholders that are there. Seminars, workshop would be held to sensitize the various stakeholders that are there, initiating projects for the various policy and technological interventions that are required for the sustainable development. In that, the user, academia, and industry partnership would be very much required to develop or to undertake research and development activities leading to to long-term sustainable projects that are there. We talk about integration of the sustainability, integration of the climate change. All of this would be required when we talk about the various stakeholders that are there. Basically, in this, we'll also need to integrate the marine spatial planning. So, marine spatial planning would, again, we have various active stakeholder consultation would be required. And then, how is with the data, how is the proper decision making undertaken? We would require the marine spatial planning can help us in that. Basically, what we require is understanding what kind of data is required for a proper policy at the local, regional, and the national level, which would integrate the various stakeholders that are there. And basically, an integrated approach is required when we talk about the water quality management, water resource management, the sediment classification applications, the dredging, working of the ports and the various inland waterways as well. So, how are we going to safeguard that? And proper environmental impact assessment, basically having a holistic environmental impact assessment of the various sediment related applications that needs to be seen. So with this, I'll conclude the presentation here. Thank you.